Good afternoon, everybody. One of our sponsors, Taranis Fuels, could not be with us due to current COVID-19 situation. They were actually due to be in Turkey this week, so this time would have been perfect. In fact, they're in Arizona, and that makes it a little bit difficult. So I shall be speaking directly on behalf of the company, and I've agreed with the chief executive what I'm saying and have some quotes from him. But anyway, to start with, we have a brief 1-minute video to set the scene. Thank you. So that gives you a brief introduction. Taranis Fuels is the leading producer of renewable fuel products. Its technology is patented and produces an enriched hydrogen-based synthetic gas that has many end-use applications. The first core product, which is marketed as Magna gas, as you saw, is a direct substitute for acetylene, propylene, and propane. This is used in industrial metal cutting and other metal applications. The fuel products themselves can actually be blended with traditional fossil fuel-based products to cut emissions, including carbon dioxide and CO, by up to about 50%. Those are the current numbers that we're looking at. The pipeline of future gas products includes a propane substitute for residential heating and cooking, portable microgrid power generation, and synthetic propulsion gas. So it's broad. It is really very broad. The technology has been validated thoroughly by leading academic and research institutions across the United States. Arizona State University has validated that the carbon footprint of Magna gas is 83% lower than acetylene. The Edison Welding Institute has demonstrated that Magna gas can cut a 4-inch steel plate in half the time, less than half the time. You can actually do 6 and 8 and 12 inches in one pass, which acetylene cannot do. It's quite extraordinary. Acetylene also leaves a very nasty mess as a residue on the steel. So whether you're in construction, you're in deconstruction or demolition, you probably saw the pictures of those massive cruise liners all packed up like sardines waiting to be cut up. Also, acetylene also kills more people, maims more people than any other industrial gas in the world. It's a shocker. Taranis Fuels was a presenting company at CleanEquity Monaco in 2017, 18, and 19. And this year, as I mentioned earlier, they are a sponsor. In fact, they were our hosts at dinner last night. So thank you very much, Scott, and everybody at Taranis for a delicious dinner last night. We're sorry you were not able to be with us. So here's a direct quote from Scott. He says, through our participation at CleanEquity, we have been fortunate to open many doors internationally. Our business grew from a pilot operation in Florida, a pilot operation in Florida, to more than 31 facilities across 7 states in the United States. And they are now in the process of launching a regional partnership with the largest player in their industries to supply renewable products across the entire GCC. Now, this is extraordinary. What he doesn't say is that San Diego has announced publicly that this is their favorite steel cutting gas of choice. They're in every General Motors manufacturing plant in the country, and they've got literally tens of thousands of customers. They're in similar, he's saying, we are in similar talks with the largest industrial gas company in Latin America as well. And we are launching Europe's first renewable metal cutting fuel hub in the Netherlands the first quarter of 2021. All of this has actually come from meetings here at CleanEquity. We are launching scaled operations in Turkey, and will announce our largest contracts to date in early November from Istanbul. That will be next week, as the industrial and manufacturing leaders of that country have begun to adopt our technology at scale. Ultimately, the objective is to ban acetylene completely and be able to manufacture enough Magna gas in country to be able to do that. So have a watch of this corporate video Taranis Fuels prepared during their successful commercial launch in Ankara in September. The event was widely covered in national print and actually on television. It's short, it's less than 4 minutes. Please, Connor.
This is a very industrial-based country. There's a lot of production that goes on here. There's a lot of metal cutting that goes on here, and we're excited to be here, and we think we can make a very meaningful impact.
The purpose of the event that we just did was to show the industry and the government that our technology functions just as advertised, and that it is truly a cleaner, safer, smarter solution that we can deliver in country every day of the week.
This is our first venture outside the United States, and we are here for sort of the ribbon cutting, the opening ceremony of our first unit actually functioning in this market. We can take hydrogen and oxygen out of any kind of fluid, whether it's sewage water, butanol, ethanol, and we can turn that into a green, renewable fuel. We can cut metal faster, cleaner, and we can do it at a much better cost than acetylene. Business here is done very differently. This is not America. You have to be here, you have to see the government, you have to have the titans of industry. Our partners have both, and this is the only way these projects move forward.
We had a number of the largest industrial gas companies in the country send representatives to see the technology, see the gas, and see our team. We also had leaders from critical elements of the government in the Ministry of Trade and Finance, the Ministry of Energy and Natural Resources, amongst others, that were there to see it with their own eyes working.
So we had a whole team here, made sure it was functioning right, and then we actually produced Magna gas for the first time here on their soil. We are here to sell the units that produce the gas, help them produce gas, and also try to expand that to the surrounding countries.
Our partners are extremely well connected across about a dozen countries in the region, and we've already made significant progress in having one-on-one demonstrations, building interest, building momentum, and beginning the process of selling machines in parallel with the machines that will be delivered into Turkey early in 2021.
Our goal is to be a very large player on the global market, and this is the tipping point where we begin to go international.
Not to overstate it, but this is a transformational opportunity for our company. We came away with almost non-stop follow-up interest from industry, from the government. We were on national television, national newspapers. This is very exciting times for us. The Turkish market is very large. It is very exciting to be here, but it is the beginning of many other opportunities that we hope and we expect will come directly from this platform we've set forth here.
Thank you, Scott. So Taronis has a cleaner, safer, smarter, and cheaper product. The four big ones, exactly what you need. Technology supports directly the shift to hydrogen and hydrogen-based renewable fuels. It supports water conservation. This is something that I find exceptionally important too. Acetylene, just to manufacture acetylene, is 3 billion gallons of water a year, which are unrecoverable. Magna gas doesn't need any. So that saving is absolutely massive. It's virtually emission-free. And add to that vast improvements in the worker safety that we talked about earlier and the labor efficiencies. If you can cut something in half the time, then that's a huge benefit to construction or deconstruction. So the closing message from Scott is, again, we have made great strides since we first participated at CleanEquity in 2017, and we are deeply appreciative of many of the relationships, connections, and opportunities that came from the CleanEquity conference. Thank you all very much for the opportunity to support this event as a sponsor. Scott, thank you very much. We appreciate all the work that you are doing too, you and your team. It's an extraordinary achievement. Well done. So now, Connor, I think we move on to the next company, which is C-Power. I shall hand over to you.
Thank you, Mungo.
Thank you very much.
So up next, as Mungo said, we have C-Power, and Vinci Lessman, CEO, is with us.
Hi, I'm Vince Leesman, CEO of C-Power. Before we start, I'd like to thank Innovator Capital and CleanEquity Monaco for the opportunity to talk with you today about where C-Power is heading and what we're doing to help our customers reduce costs, operational complexity, and avoid carbon emissions. At C-Power, we deliver products that provide power, energy storage, and real-time data and communications for offshore energy, defense, security, aquaculture, and research markets. In a way, you can think of our systems as the combination of an EV charging station, a data server, and a cell tower, all in one package, but out in the ocean. So why is this important? To answer that question, let's start with today's ocean economy. Doing work, collecting data, doing really anything offshore, it's people intensive, it's carbon intensive, and it's expensive. The ocean economy is this way because if you're doing most anything offshore, it requires bringing both power and people along. You need a ship and a crew to provide the power, and it's precisely this manned, carbon-fueled operational model that is the issue. The level of technical innovation in the ocean is not where it is on land, and this is not where our customers and their suppliers want to be. Where they want to be is an environment where autonomous digital connected systems dominate. They've made significant net zero goals that they've pledged to meet. Entire industries in this $3 trillion ocean economy are transforming right before our eyes. And there is significant technology development underway. New technologies providing safer and cheaper, easier, more connected, and cleaner operations are emerging. And what I'm saying is no different than if I stood before you 10 years ago and said there would be EV charging stations everywhere, that wind and solar would represent the overwhelming majority of new generating capacity being built, or that Amazon was going to deliver your packages via aerial drone. All of these innovations are coming to the ocean economy, but innovation requires power. And that's such a basic connection that we actually don't even think about it anymore. Without power, you can't really have technical innovation, because on land, power is almost always nearby. But the ocean, it's a power desert. There are no outlets, there's no transmission lines, expensive, dirty diesel fuel can't do it going forward. So where is the energy going to come from to power the new ocean economy? Quoting a large fleet operator that we work with, I need a plug in the ocean to do what I want to do. From another tier one supplier, the problem is always getting power in and data out. From another, the goal is always just to get rid of the topside vessel. Lack of power is an absolute obstacle to delivering the new ocean economy. But sea power provides the solution. Our products transform that desert into an energized, data-enriched environment and provide the technical capabilities needed to unleash innovation offshore and unlock this massive transformation in our targeted markets. In those industries, they understand the importance of our system and just how critical it is to get power where there is none today. I believe the quote really speaks for itself. Our customers understand this because they realize how significant our value proposition is. The whole goal of the transformation in the ocean economy is to reduce costs, reduce complexity, enable new hardware, software, and service capabilities, and to decarbonize. Our products are specifically geared to deliver these objectives. Just one Sea Ray autonomous offshore power system can save a customer up to 100,000 euros a day and help them avoid producing about 7,000 cars worth of CO2 each year, all the while enabling new, robust, innovative capabilities. We have 3 products coming to market. The first one is the Sea Ray Autonomous Offshore Power System, or AOPS. The technology behind the Sea Ray originated in a US Department of Defense project a few years ago. But let me show you a bit more detail about the AOPS. Sea Ray consists of a device on the surface that captures and converts the ocean wave energy into electricity. We store that energy in batteries on the surface, in the Sea Ray, and on the seafloor. We're able to provide real-time data and communication support. And this is important because, excuse me, it allows remote command and control of assets. It allows more robust data to be collected and live data to be fed into the cloud. Our systems can be deployed in shallow or deep water. They're easy to transport and deploy. The AOPS for our groundbreaking sea trials this winter, it's being shipped in 2 ocean containers and deployed with a small workboat with a 4-person crew. No one else can do this. The Sea Ray can support a wide range of systems, unmanned vehicles, sensors, operating equipment. We can enable 24/7 monitoring, data gathering, and inspection packages with both static and mobile assets that can be left in place for weeks or months or even years at a time. Our customer hardware and software services are being prepped for residency. They just need power. And there is a long, varied list of use cases. These tend to revolve around either permanent or campaign-based residency. The image on the left shows a counter-drone package, for instance. This includes an aerial, surface, and subsurface drone detection, but that's just one example. For oil and gas, a resident AOPS can be used to power remote brownfield sites in an emergency basis or on a permanent basis. This helps to lower cost, carbon, and complexity for those customers. On the campaign-based side, it's a system that gets dropped for a few weeks before that wind farm gets built to do a UXO, an unexploded ordnance survey. Or post-construction, that same system can inspect all of the subsea assets, then be picked up and moved to another part of the farm, or even another farm. Or the AOPSs can be arranged like EV charging stations, and the vehicle can move from station to station, executing their mission, getting charged, dumping their data, and then moving on again. All the while, again, saving substantial carbon cost and complexity. But none of these applications can be done today without an expensive ship. I've listed some of our significant recent accomplishments. Among the headlines I'd like to bring to your attention, we sold our first product earlier this year to the US Navy. We've received 44 patents to date. There are more on the way. And we've already gotten some of the industry's top suppliers involved. We are focused on the sweet spot of this market. This is what I call the 10 to 10 gap. This is the gap between 10 watts and 10 megawatts. For loads less than 10 watts, a small solar cell can supply the power. For loads larger than 10 megawatts, offshore wind, either floating or fixed, will likely handle the load. But between 10 and 10, which is where the majority of the loads in the ocean reside, there is a gap with no power solution. And our products uniquely fill this gap. We have the watt scale data array, mainly for oceanographic research, navigation, and data gathering applications, the C-ray, which we just discussed, and the Stingray, which capacity ranges from hundreds of kilowatts to megawatts. The C-ray and the Stingray, they serve similar markets. An example of a Stingray application would be to replace the diesel genset in an offshore fish farm. Doing so results in an operation that's cheaper, it's easier, and it's better for the fish and the humans. We have a robust commercialization pipeline. The code after each of the product names denotes its power capacity. So for instance, the C-ray W100 is an AOPS that has 100 watt capacity. This is the system that we're delivering to the US Navy this year. Each product we release opens significant new markets and applications. Happy to discuss this more in the Q&A. But I want to give you one other quick detailed view at the market data here, this time sliced by market in application. We have a massive opportunity ahead of us. And it's not necessarily something that everyone thinks about every day because the ocean, it's a bit out of sight, out of mind. But our addressable market is big and it's on the way. Our competitive advantage is set on multiple levels: IP protection, design approach, and team strength. Our decades of experience in our customer-focused product development process, they allow us to rapidly innovate and deliver highly differentiated, lower-cost products that are specifically designed to meet customer needs. The DoD product I mentioned went from an idea from the whiteboard to water in less than 10 months. The groundbreaking C-ray product is being delivered on a similar timeline. Legacy competitors they're recycling old utility scale designs that cannot be effectively downscaled for lower power markets. They're just not fit for purpose. Newer entrants lack saltwater experience and are years from commercialization. Comparatively, we're superior in all the metrics that matter. For instance, one of the most important is power to weight ratio. Weight is cost. So producing more power with less weight, it's important. Our competitor systems weigh 4 to 10 times more than ours and produce less power. All the competitors are depth limited, we are not. They just can't come close to our simple, low-cost operational profile. We're the global leader. We've got a great team. We've got hundreds of years of operating and engineering experience in energy, early stage, and Fortune 500 companies. Our management team, founders, board, corporate advisors have been involved in dozens of startups and renewable energy companies. We've had numerous of those companies go public. We've been top executives in companies like GE and have developed over 2 gigawatts of wind and solar projects. We intentionally keep our internal staff relatively small. And that's because we focus internally on where we can build IP and where we need core competencies. We outsource the rest to avoid trying to reinvent the wheel. Just no need for that. Our international supply chain that we've built can help us deliver our products worldwide. We do, however, have a number of hires to make, mainly in Europe, and this is part of the use of the proceeds of our current Series C fundraising. We employ a highly capital efficient business model in which we bring funded development to our potential customers and our distribution channel. The integration effort represents low investment by that partner, and the market feedback that we get, it's invaluable, and it helps us deliver fit for purpose systems out of the gate. This is why the C-Ray is so advanced relative to the competition, and it's happening so quickly. We will sell our lease to our partners who will sell the integrated hardware and services packages through to their customers. I think one way to think about how we work with our customers, our direct customers in our channel, is the old BASF tagline. We don't make the things you buy, we just make the things you buy better. There are also innovative business models that we need to investigate where the customer pays for usage rather than a capital purchase or a lease. Just like your utility or your internet provider, we would charge by the kilowatt hour consumed or the megabyte transmitted. We are opening a Series C round now. This is a $6 to $8 million raise to build out our team, execute our product development roadmap, and build our sales, marketing, and channel partnerships. With the funds, we get 3 products into the market. We achieve repeatable sales, and we deliver profitability by late 2022. We've brought in $38 million US so far. 13 of that is private capital. The balance is non-dilutive grants. Now, I believe this small amount of private capital brought in to date, it underscores that capital efficiency of our model that I was just speaking about. We foresee multiple exit paths, including strategic sale of the company or sale of specific product lines. It would obviously take more capital, but I also see an industry roll-up as a highly attractive model moving forward. This would involve both horizontal acquisitions of other renewable energy companies to build out the portfolio, and vertical acquisitions to capture and leverage some of the great work being done by our value chain. So with that, I'll close. Thank you very much for your time. I'm happy to answer any questions that you may have.
Thank you, Ernst. First, I think you touched on this a little bit on the slides and on the timeline for product development and implementation. So maybe a bit more on the stage you're at right now. Do you have pilots and then the pipeline for the coming years?
Sure. As I mentioned, we have sold the first unit. We'll deliver that by the end of the year. That is a drifting 100-watt C-Ray being sold to the Navy for underwater vehicle charging R&D. Our C-Ray K2, which is a 2-kilowatt system, is in the process of being built now. It is going to be deployed in Hawaii off the U.S. Marine Corps base in Oahu in about 80 meters of water. We'll be operating a number of sensors and a subsea vehicle from that deployment. That is a commercial ready system. So those sea trials are meant to launch that product. So we'll be launching the C-Ray commercially in 2021. The data ray product, and I can back up here actually. The data ray product comes out in about a year and a half. This is a smaller system that fits inside of another product like a navigation buoy, and it harvests the motion off that buoy to help supplement the power supply. And then the Stingray, which I also mentioned for aquaculture and for other larger capacity operations, that's around 2.5 to 3 years away from being released. So we are just starting commercialization now with first revenue this year.
The larger devices that are 3 years away or so, how much more funding is needed to develop those through?
Yeah, that's a great question. So we have $6 million worth of R&D contract backlog now that really covers that entire spectrum of devices that I was just discussing. We probably need around $6 million more between private and public capital. Sorry, that's just private capital for the Stingray, and then probably about twice that from a public perspective, but it's close.
Okay. And then finally, a little bit on the manufacturing. where they're manufactured and the plan for scaling up?
Yes, the systems are relatively easily built. The trick for us is in the IP protection, but we have, for the Sea Ray that's going to Hawaii this winter, hull fabrication is taking place in the Pacific Northwest in the US. We have a smart component, the seafloor base unit that's being manufactured in Aberdeen, UK. The mooring lines, which are special built for us, are being produced on the East Coast of the US. So we've already assembled really a very far-flung supply chain that's coming together very nicely in spite of the current environment. But the systems can be, for the most part, can be manufactured. The hulls can be fabricated close to where they're deployed. But we have designed the system so that it is very easy to transport anywhere worldwide. This is the Sea Ray model and the Data Ray model. Again, we're sending those to Hawaii in 2 ocean containers. So we're a little indifferent on the smaller systems as to where they need to be manufactured because they are so easily transportable.
Very good. Thank you very much. Thank you for joining us, Ernst.
Yes, thank you, Connor.
So up next, I am pleased to introduce Jacques at Ingenuity Power Systems, and I'll hand over.
Good afternoon. Hope you guys are doing great.
Good morning.
I want to introduce Steve Nicewander, one of the founders of Enginuity that joined me for this presentation. Good afternoon from Washington, D.C. With the COVID situation, we're grateful to the organizers for setting up video streaming, even though I know some of us are developing allergies to Zoom meetings, including me. We'd much rather be there in person. I'm Jacques Beaury-Lozic, president of Ingenuity Power Systems, and with me is Steve Nicewander, one of the 2 original co-founders of the company. So let's jump right in, Steve.
The company was founded in 2015 and consists of the headquarters in Washington, D.C., and a contract manufacturing company in Detroit, Michigan, which generates $5 million in annual revenues and provides technology development services to Ingenuity. Ingenuity at its core is a company that has designed, built, and tested a family of new generation combustion engines. After years of prototype development, the team realized that the engine would be ideal for a home-based micro CHP unit. The team then began development of a patented micro CHP unit with the help of the Department of Energy and U.S. National Labs. This system became an award-winning product in February 2020 when it won 3 awards at the International Builder Show: Best in Show, Best Energy Efficient Product, and Best Home Technology Product.
With all the concern about climate change, the grid is an increasingly wasteful, unreliable approach to bring energy to consumers due to waste heat and transmission losses. 1.1 gigatons per year of CO2 is wasted on account of waste heat in the US alone from power plants. And all-electric solutions are very inefficient for heat. A European study shows that converting all residential heat needs to all-electric would increase electricity consumption per household by up to 10x depending on the technology utilized. Where will the extra power come from? Where will the extra transmission lines come from? Our solution produces power and reuses the exhaust heat and engine coolant for a total efficiency of 90% and is black start capable. It is timely and takes advantage of US policy changes and those already in place in many European countries, facilitating the use of distributed energy resources across the board. Our solution can reduce fossil fuel usage, reduce CO2 emissions, and provide substantial benefits to consumers. For investors, the US market alone is larger than $100 billion. Steve, can you explain to the audience what's the secret sauce behind E1?
Sure, John. The key component of the E1 is our patented engine. Because of its compact size and multiple power takeoffs and low vibration, this allows the system not only to produce electricity and hot water, but also provide other uses such as cooling and dehumidification. It is specifically designed to run inside of a home. E1 is our current flagship product, driven by our new engine platform. and it will generate 8 kilowatts of electricity on demand while replacing your hot water heater and supplementing or replacing your furnace. You can see in the picture how our engine is integrated with the optimized thermal storage tank. It will also play the role of an emergency generator. All of this at a targeted cost of $10,000 at scale. You can think of it as a 3-in-1 unit. We call it the whole heart of the home.
An important feature of E1 is that it will facilitate transactive energy management. What is transactive energy management, or TEM? TEM is a new approach for energy management and trading, which can be used to facilitate the integration of distributed energy resources in existing networks. The key feature in TEM is using market-based solutions for better energy management, generally based on price signals. We believe that E1, with its ability to provide power almost on demand and its ability to complement solar, can be a big part of enabling this TEM solution. We're in discussions with a key few software developers as potential partners to provide TEM services to consumers and utilities, which would integrate directly with our E1 platform. We'll market E1 based on 6 major benefits: super efficient, consumer savings, durability, easy to integrate, compatible with solar, and environmentally friendly. In this diagram, you can see how the E1 integrates with all of the home systems and with renewables. We call it the heart of the home, as you said. So what am I looking at if I am a consumer trying to buy a new home? Do I want to go with a traditional HVAC package, which includes a water heater, a furnace, and an emergency generator? Do I want to go with a Trendino solar and battery package? Or do I want to buy E1 and maybe add a small battery to help smooth load unbalances? Well, the traditional package would cost you around $11,000 for a standard American home, as well as $2,200 per year in utility bills. To get a solar package with benefits comparable to E1, which means servicing the home for heat, you would need $31,000 of solar panels, a $6,000 heat pump, a $6,000 battery, a $5,000 emergency generator, and a $2,000 water heater for the modest sum of $50,000. Of course, we all know a consumer would never do that, even with subsidies, which reinforces my earlier point that all electric is ill-suited for heat. With E1 savings, I would pay back my systems in 2.2 years versus an 18 years payback for the all-solar option. I didn't include US solar subsidies for solar panels and no subsidies for the E1, by the way. Yeah. In reality, I believe what will happen is hybrid solar, micro-combined heat and power, battery systems integrated with the grid may become the best of both worlds, with lower cost, high reliability, and very low greenhouse gas emissions. Now let's talk about the market. In the US alone, there are 70 million homes that use natural gas or propane for water heating and space heating, or about 60% of all homes. We're targeting states with high spark spreads and strong support programs for energy efficiency. Spark spreads represent the difference between electricity and natural gas prices. So with these criteria, our top 10 states include the Northeast, the Midwest, and California, where we all know that resiliency is a big issue these days. Beyond the US, Canada is also an ideal market for our products. Ontario alone has 4.4 million natural gas homes. In the EU, 45% of all homes use gas heating systems, and the market is supported by significant incentives in many countries. This is a more detailed view of the US market potential for E1 by 2030. There are 600,000 new US natural gas homes built every year and 7 million retrofit opportunities in our top 10 states alone. Taking 10% of new natural gas homes market share and 5% of retrofit opportunities would yield 420,000 unit sales annually. We believe we can hit these numbers faster with the right supply chain partners and the right scaling strategy. Our 20 kilowatt unit E2 will help us target an additional 8 million US sites, from high-end homes with pool to small businesses with high thermal loads, such as car washes and spas, for example. We believe this market to be ultimately as large as that for E1, and this program, I would say, is running about a year behind E1. Steve.
We've invested substantial resources in our IP protection for our engine architecture and major features, as well as our combined heat and power technology. We have a total of 28 patents issued and pending. Our applications cover the US and the EU, and we're beginning to file in Asia as well. We believe that our IP is solid and hard to work around.
Thanks, Steve. Our business model is quite simple. We design and sell products close to what Apple is doing, except that we do not sell directly to home or business owners. We aim to bring great product designs to the prototype stage and to sign manufacturing agreements for our engine, sourcing agreements for the water tank and other components, and manufacturing assembly agreements for the MCHP unit, whether it's E1 or E2. We have many ongoing discussions to that effect. We aim to sell the product to distributors and wholesalers, but may initially have innovative financing and warranty solutions. We may receive ancillary revenues from licensing our engine to third parties for applications that do not compete with ours. We have a strong management team with entrepreneurial founders with deep automotive expertise, supplemented by additional talent brought in at different stages of the company's growth as needed. We're also complemented by a high-level advisory board, which helps us extend our core capabilities on items such as policy, financing, or battery integration, to name a few examples. We also have a strong resume book to fill in the legal, finances, and commercial functions once we complete our round of financing. Well, now, welcome to Ingenuity's version of the hockey stick. I'm sure you've never seen this in Europe, right? I know it's a malign term, but this is truly how successful companies end up once they hit the commercialization accelerator. In our case, we request capital to move from the toe to the shaft of the hockey stick. For those of you who are familiar with hockey like me, since I was born in Canada. Between 2020 and 2022, revenues will mostly consist of sales from our Michigan affiliate, government program revenues, and revenue from prototype sales deployed in pilot programs, likely to be loss leaders. From there, we look to sell 10,000 units in 2023 and more than 20,000 units in 2025. We're foreseeing our EBITDA to be around 50% of sales, consistent with current appliance makers. Now, this chart shows that we aim to achieve positive cash flow by 2024. While this round should bring us to 2023, we will need a final round of growth equity to fund working capital cash needs to grow the business, and this will make us sustainable going forward.
In this presentation, we've primarily focused on our E1 product. However, our platform is easily scalable to smaller and larger applications. The US government is very interested in our technology, especially the Department of Energy and Department of Defense, because of our power density and overall performance profile. We have one contract with each department, as well as $12 million in the pipeline through several grant applications. As investors, you're investing in more than the E1 and E2. You're investing in a platform that includes portable power generation, unmanned aerial vehicle propulsion, serial hybrids for EVs, pool heaters, industrial greenhouse, and district heating applications. Our wholly owned subsidiary, for example, has a 250 kilowatt LPG engine that would be ideal for larger scale applications.
So in summary, we're looking to raise $50 million to establish E1 in the marketplace. These funds will be used to complete our management team, build and deploy prototypes, achieve our target commercial specifications, secure our product certifications and permits, and sign multiple initial manufacturing agreements and commercial deals. So thanks for listening. We hope you've enjoyed our presentation, and Steve and I are really looking forward to your questions. Thank you.
Thank you.
So you mentioned that a little bit, but could you go a bit more, please, into the IP coverage focus and the strategy going forward?
So our patent portfolio, we started, our company is based on engines and the engines we invented. So we circled not only on the overall package or engine, but also the internal components that make it unique in the configuration. So it focuses on that. And then moving into the E1 flagship product, we not only, the IP on that is based on the design. If you see the picture there, it's on the engine integrated with that tank all together in one package, the actual shape and the functionality of the shape, as well as anybody trying to copy that shape or put a different engine in that configuration, not using our engine, we actually have coverage on that also.
Thank you. And then there have been attempts over here in Europe that are very similar in MCHP. For example, Genlec, flow boiler in the UK and Netherlands. So how might Ingenuity succeed where they appear to have struggled?
What we found doing our studies before we decided to build this product was that most of the other companies had went about it by taking an engine that was used for a different purpose, running on diesel or gasoline, and converting them over to natural gas or propane. The difference with our company is our engines, we own those engines and we control them. And so when we decided to make this product, we redesigned our own engine just to run on natural gas, just to run in a home, to have almost no vibration, very efficient, that sort of thing. You would never put some of those engines in a home. We consider this first product, the E1, as a high-end appliance.
Yeah. A couple of other factors also, Connor, I would add is also the US, the presence of very large spark spread due to very cheap natural gas prices for a very long term, as well as the emergence of transactional energy management and the ability to use net metering across a lot more states and be able to play timed generation. And also I would say, paradoxically, the emergence of solar and batteries make it a very nice complement to our technology as well. We can help make renewables more reliable. And I think the package of PEV and MCHP together is potentially more powerful than each technology alone. So I think there's a lot of technology trends that make the situation very different than 10 years ago, as well as our unique competitive advantage, like Steve said.
Okay, thanks. So what other markets have you identified then beyond US and Europe?
Well, I think all the market with high spark spread and very unreliable grids, there's a lot of emerging markets in Asia. And Korea, for example, is a market that's very attractive to us. Australia, ultimately countries like China and Russia would be interesting. But like you said, with the US market alone, I mean, with half the US market alone, we can literally really have a substantial liquid market right there just to get started.
And then, question coming up.
I didn't mean to interrupt. Please finish your sentence. I wanted to ask, could you say something about the efficiency of the heat or the energy, energy utilization that you achieve and how that compares with the best known to you alternatives?
Well, right now, our engine, our specification is 90% efficiency, so 35% heat, 35% electricity, and 55% heat. So you compare to the grid, for example, the average grid in the US is 34% efficient, and you have a 5% loss transmission, which is 29% efficiency. So as long as we can recover all the electricity and the heat for a home and we can utilize the heat, it's 3x more efficient than the grid. So, but even if you have an electrical appliance that's 96% efficient and that uses the grid to supply the power, you still net around 30% efficient. I would say we compare well also to other MCHP technologies because of the unique nature of our engine. That we believe that engine side would be the most efficient engine of that class. So we believe we're an incremental improvement about existing MCHP technologies like Myanmar, for example.
Thank you.
And then, would a syngas, not necessarily grid quality, be usable for extreme distributed applications?
Yeah, we could use a syngas. I mean, we could use landfill gas. We could use, depending on the quality of the syngas, you may have to derate the unit a little bit, but we're very flexible. We can run natural gas, propane, renewable natural gas. We are also studying mixture of hydrogen and natural gas as well with GTI. So there are a lot of ways to even reduce our carbon footprint over time with the technology we have.
And then, can you share a bit more on the financials for the end user, the customer, the payback and the costs?
Yeah, well, I had a slide in the presentation that was attempting to address that. Of course, there's like hundreds of different scenarios depending on which country, climate zone you are. But net, water story is there for a small incremental cost versus traditional HVAC system. You can save in the US $100 to $200 a month in your utility bills. And on top of that, you can benefit from net metering revenues, especially due to FERC Order 2222, which is going to open many markets to this option going forward. And we believe, we've done a lot of analysis that we believe a 2 to 6 year payback is reasonable in most states.
The simplest math is the product costs $10,000. The customer is going to average about $2,000 savings a year without selling any electricity back to the grid or doing any net metering. And so the system, right now, the 10% tax credits, so $9,000, 2 to 3, 2 to 5 years, depending on the use. The system, the difference also, and make sure we understand, our system is designed as a high-end appliance, so it does not run nonstop. It runs when needed, when it's smart to run. It will not run if the power coming from the grid is really cheap. It'll run. It only runs when it's really expensive. So it's a smart device.
Thank you. Well, thank you very much for joining us, Jacques and Steve, for the Q&A. Thank you very much. That was very interesting.
Thank you for having us. We'd much rather be down there with you guys.
Very much so. So moving on next, we have Biomass Controls, and Jeff Hallowell is ready for us.
Well, good afternoon. Well, thank you to His Serene Highness Prince Albert of Monaco and Mungo Park, the innovator of Innovator Capital, for hosting this event. I'm Jeff Hallowell, and I'm the founder and chairman of Biomass Controls PBC. We are a public benefit corporation, innovative solution for decarbonization and global nutrient recovery. Our refinery that's illustrated here and also right behind me uses a thermochemical process called pyrolysis. It reduces volume, it kills pathogens, it also removes microplastics and produces thermal energy. We design and build our decentralized technologies to reduce greenhouse gas emissions and recover nutrients from green waste. We generate thermal energy and can operate in sub-freezing conditions. Our refineries are transportable and can be set up in a day. We built 14 refineries, and 3 of them are illustrated here. The one on the left is in Alaska, where it can be minus 40 C. The one in the center is at a dairy farm, and that's reducing emissions from dairy manure solids, which reduces greenhouse gas emissions by 50%. And the system on the right is one of 3 that we have in India that are processing the solid waste from about 50,000 people per day. So here's the system that we mentioned before. It's a refinery. We also have one behind me, which is done combined heat and power. These are the 3 systems I talked about earlier. The one on the left is processing waste at an Eskimo village up in Alaska. The one in the center is at the dairy farm. And the one on right is one of the ones that we have running in India. Obviously, carbon is a nutrient, and managing that is very important. There is a lot of issues where most of the nutrients, like carbon, end up in our oceans and also in landfills. So by efficiently managing them, not only can we return them into the soil, but also get rid of things like persistent chemicals and prevent leaching, like problems in some areas like phosphorus. So right now there is about 1.8 billion people that drink water with human waste in it every day. So we do need to manage that more effectively. It leads to about 2,000 children dying every day from sanitation-related diseases. Here's some of our milestones. Our first system did go to Alaska, but really we started the company through the Bill and Melinda Gates Reinvent the Toilet Challenge, and our first sites through that challenge ended up in India. We built a total of 7 systems that went to India, and 3 of them are running in these sites. Other things that are important here is our breakthrough technology recognition by MIT, and we have an ongoing project that we're working on with the European Space Agency, and that's using image data to also map to sanitation and nutrient management as well. In 2019, we did get funded from Water Equity Water Credit Fund. That's through water.org, which was founded by Matt Damon and Gary White. We also last year got some debt from convertible debt from MFA Oil. MFA Oil is Missouri Farm Association. They're a $1.1 billion co-op focused on energy in Missouri. And currently we're part of Launch Alaska Accelerator, which is, has a lot of military background to it as well. Our Biomass Controls team is very experienced. Our board and our advisors, for example, MFA through the debt investment, we also got their CFO on our board as well. So we have a very good team to put together. My background is more Silicon Valley. Derek is really in renewable energy and bioremediation. Jeff Wong, our CIO, is in network, and Allison is our gender advocate, and she helps us with the global health as well. Here's a picture of biochar, which is what comes out of our system. So it's very nutrient rich. The pyrolysis process is not incineration. We actually keep that carbon, which is the most important nutrient in there. We also reduce volume. So as you know, moving liquid is very expensive. That's why breweries are popping up everywhere, because moving liquid is very expensive, but also now you've got a waste. So there's food waste, human waste, and ag waste that's typically needs to be managed. And by reducing it, you can also reduce odor, greenhouse gas emissions, and use that to put back into the soil. So there's one example that we have here. We believe that investments should cover a multitude of strategic development goals. So if you can reduce greenhouse gases, improve the climate by also saving the lives of children and helping feed people, that's really important. So we believe that our focus on sanitation, or what we would call wet green waste, it really affects 14 of the 17 strategic development goals. Our product is resource recovery, but attached to it is a lot of technology. We do data management and reporting. A lot of it is evidence-based, so there is a lot of evidence base that's needed to sell the greenhouse gas credits, also to prove that there's treatment. During COVID, we've kind of adapted. In the top right corner, we've signed with 2 companies to do manufacturing for us. One is B Engineering, they're an aerospace company in South Africa, and one is Kalyani Group, a $2.5 billion privately held company in India for the manufacturing of our system. We're still supplying the controls and the infrastructure, but now we've basically reduced our cost by having it done closer to our customers. Our competitive advantage is moving from a centralized model to a decentralized model. The way we've treated green waste for thousands of years has been a centralized model, whether it's been a sewer treatment plant or a landfill or a recycling center. And this really, we really need to break out of that and move to a decentralized model where we realize that the transportation of the material is really the higher cost. And if we can treat it closer, then that's really where we're going. So right now we're in a decentralized model, but I think very soon we'll be going into a mobile model. Also, you have to be flexible to work in cold climates. A lot of aerobic or biologic systems do not work in cold climates. It's very specific, and it's very, very fussy. Also, we've done a lot of innovation, as we'll show in a second, with a lot of the patents and software control that we've done. Sanitation is ubiquitous, just like food waste, so it is a growing market and it affects a lot of folks. Only about 5% of the world has waste that is treated properly. Most of it does end up in the ocean or in landfills. There's about a market of about 8 billion that is really the early adopter. So just because the market's out there doesn't mean everyone's going to buy it. So that early adopter market is identified at around 8 billion. Right now, we are spread out in warm climates and cold climates, where we have a big focus in India, where they have for several years now been focused on improving sanitation, because they know that for every dollar invested, there's about a $5 return in improvement. But that's basically getting people back to work, sickness, and also trying to help people from dying as well. The global market is about $1 trillion, and that's based on a figure of 100 US per person when the population is around 10 billion. And so that number is just for sanitation. We know that human waste, we know that food waste will also be bigger than that as well. So we currently have 20 patents. So we have them in the US, Canada, Europe, and Australia. And they have to really do with 3 areas. One is pollution and fuel to air management, the carbonization, or how we develop and how we process the green waste, because it's wet, we have to dry it and we have to produce the carbon. And then the third is how we generate electricity using the heat. We started the company in 2015. We've been growing pretty steadily. This year, we have slowed down with our installations based on COVID, but we expect that to pick up now that we've done licensing in countries as well. We have infrastructure as a service model. We do expect a lot of revenue long-term from data services, whether it's storing the data and data reporting. And we believe that our systems can also be used for other technologies out there to collect the data. The investment we sought, we're looking for a 3 to 6 million convertible debt, or 15 to 30 million Series A in Q2 of 2020. We're going to build out our team. We're ready to scale. We're moving into standardization. We've had a number of commercialization right now, but we're working on standardization with TÜV Süd out of Singapore to meet the ISO 31800 standard. Also, the financing we've got is for inventory, but we'd like to expand that in other countries as well. For example, the water equity money is specifically for funding our expansion in India. So thank you very much for your time. Sorry for the technical difficulties early on. And if you have any questions, or if you want to talk offline, LinkedIn is there on the profile for the event, and also our emails are there, and my CEO, Derek, is there as well. Thank you very much.
Thank you, Jeff. Can you please expand a bit on the IP you have and strategy going forward?
Yes. So there's three IP. One is our design. So we have design of our electronics and also of our system, which we license our system, but we do not license our electronics right now. We sell those. The second is our software. So we use software to run the system and control it. And then finally, we have our patents. So we do license those. Some of them are design patents and some of them are methods. So some of them are captured in our software and part of that. And some of them are, we license them through the manufacturing of the systems as well. So currently we're getting royalty fees for that, for our design. And currently we're charging a monthly fee or a per person per day fee for use of our system.
And
Does that answer your?
Yes. And then on the source of the material for the feedstock.
Yes. So the source of material we prefer on site, and so resource recovery on site is really part of the circular economy. So we process, for example, the dairy manure on the dairy farm. We're in the village, for example, up in Alaska. We're doing some food waste work up in New York. We're putting food waste in a landfill, and by 2022 will be illegal. And so on site is the best. So that's where we believe decentralized is better. Food waste, for example, human waste, it starts to break down very quickly, and the faster we can process it, the better. So on-site is where we're driving towards.
Okay.
Yeah.
What do you do with the oils, the wax byproduct, and any other byproducts besides the char?
So we process, as part of our patents, we use a catalyst, a specially designed catalyst that we run the oils and gases through, and that's what generates the heat to provide the drying of the materials. So that's one of the challenges for us. There's a lot of systems out there that will make biochar as a product, but it's usually for very dry materials, usually less than 15% moisture. A lot of ours comes into our process around 85% moisture after it's been dewatered. And so we use that energy in the form of the gases and the oils to dry it as it comes in and just leave the nutrients and the carbon behind.
Okay. And then the key markets for the next 2 years.
The key market for us is from a humanitarian impact perspective, we're really focused on sanitation, so Africa and India, and really focus also on training women to run the sites so that we can affect SDG 5 and enable, because women and girls it's a great market for them. But in the States, we've been really focused on ag tech because ag tech is money, and that will help fund and offset some of the cost for sanitation. So those are our two big markets right now: is food waste with human waste, and also ag residues. The ISO standard actually calls for 51% human, so the other 49 can be other things. So any kind of a green waste, ag residue, food waste, and human waste are components of that as well.
Thank you. Thank you for joining us today, Jeff.
Okay.
Great.
Thank you, Connor, and
No
thank
worries.
you to all the sponsors as well.
Thank you.
Yeah.
So moving on to the next presenter, we have You First Services, and I believe we have Dr. Sharma with us ready.
Mr. Barrett?
Yes, we can hear you.
Okay, good. So I have Dr. John Loddy. He's the Executive Vice President for our engineering programs with You First Services and in charge of the Steady Space program. With a little bit of my voice issue at this time, he's going to be presenting the information about Steady Space, and I'll be here to answer any questions. So, Dr. Loddy.
Thank you, and good morning, at least in this part of the world.
Mr. Barrett, can you hear us?
Good morning. Yes, we can hear you.
Okay.
Thank you.
We're addressing a novel technology to control and prevent airborne infections. And with the substantial improvements in technology and transportation, the spread of airborne infections has become a worldwide problem. And we're particularly, as a number of people are focused on COVID-19, but there were earlier pandemics, SARS, MERS, and then viral infections that have been with us for a long time. Influenza, tuberculosis, measles, and also meningitis. Healthcare facilities worldwide are focused on providing internal air quality. And at this time, poor air inside can make a single instance of an illness flash through a residence, a hospital. Such unwanted circumstances can unfold quickly if they're not managed carefully, and particularly in vulnerable patients, the elderly, young children. The infections can lengthen recovery periods for some time and indeed risk death. There's been also a substantial economic impact, the loss of revenue in various forms of businesses, particularly airlines, cruise companies, amusement parks. The lost earnings and the decrease in gross domestic product from many countries has approached serious proportions. Surveys that are done in February, the U.S. output fell to the lowest level in more than 6 years, and global economies started to feel the effects of the outbreak from China. And that's overburdened a number of the healthcare systems. Economic impacts that have been documented in MERS back in 2012. In the Arabian Peninsula, the global cost was $16 billion. The SARS outbreak in the early 2000s spread to 23 countries. We are particularly close to Canada in Buffalo, New York, and the cost of the SARS outbreak in Toronto was striking. The COVID-19 has spread to over 40,000 infections, 40 million infections as of yesterday, and over 1 million deaths. And the global cost has been in the trillions. Tracing the history of this, the first case of coronavirus spreading across the globe happened back in November of 2019. By the end of December, the end of 2019, the World Health Organization notices for the first time a pneumonia spreading through Wuhan, China, and was later designated COVID-19. And March 11th of 2020, the World Health Organization declared a worldwide pandemic. And then in July of this year, there were over 230 scientists in 32 countries who sent a letter to the World Health Organization about COVID becoming airborne transmission. And they updated their findings later in July and talked about spreading through aerosols. And only recently, a little over a week ago, CDC updated their description of the spread of COVID-19. So it took a year to realize and warn the airborne infection potential of COVID-19. And we're proposing the use of our SteriSpace to limit this spread and save lives. Airborne infection, well, that's, the biological pathogens aren't the only risk for airborne contamination. There's all kinds of air pollution issues, and they're known in various locations around the world. And the sources from vehicle industry are a serious cost. Transportation is responsible for a lot of the air pollution. And this view graph designates what the contaminants are and what the main sources are. And they're vehicles, house heating, power plants, other human activity, and natural sources. And the main pollutants are listed on the left, where you see the gaseous contaminants, nitrogen dioxide, ozone, volatile organics, formaldehyde being one, carbon monoxide, and the polycyclic aromatic hydrocarbons. There are also solid matter, which if that's significant output of one of the sources, then we need a filter for that particulate matter. The health risks associated with air pollutant exposure, a decreased lung function and growth in children. And that's exacerbated if they have allergies, asthma. It causes nose, eye, throat irritation, and can cause permanent organ damage. And also can cause cancer. SteriSpace is a technology that utilizes a proprietary patented compressive heating process that can provide air clean and free from biological contaminants. Our device has been independently tested by the US Department of Defense and demonstrated the kill effectiveness against bacterial spores and viruses with greater than 99.9999 or 6 nines biological contaminants. And this is how the technology works. Air is pulled into the machine, compressively heated to a high enough temperature to kill the biological contaminants, bacteria, viruses, fungi, and then energy is recovered with a very high effective heat exchanger to cool the flow back down from our high temperature. And then the sterilized airflow can be cooled down to temperatures that are essentially approaching room temperature and can be then used to feed an HVAC system. And also sometimes the waste heat in various climates can be useful in the winter months. The sterilization to the system is I can't see that.
Yeah, you can go skip to the next one.
The use of SteriSpace is an innovative technology that provides solutions to airborne microbial sterilization challenges. SteriSpace achieves consistently substantial reduction in the contaminants, providing a quality and thorough sterilization. As we mentioned earlier, it's been tested and shown to destroy better than a 6-log kill of biological pathogens, bacteria, viruses, fungi. And the heat from the unit can be used and redirected as well. The main feature compared to current technology is it eliminates worker exposure to biohazards on a filter surface and can be configured for positive or negative pressure applications, meaning either the protection of the patient inside a room or the protection of the environment outside the room of a contaminated patient. Isolation or quarantine for highly contagious patients, such as COVID-19, TB, SARS, help contains these outbreaks. And the SteriSpace can maintain a negative pressure in the flow, in the room and exhaust the decontaminated air to the outside. This is an application which SteriSpace satisfies the number of air exchanges for meeting the guidelines, CDC guidelines for infection control. For protection of patients where you want a positive pressure in the room and prevent infiltration of contaminated air, SteriSpace can prevent these patients from contamination, especially killing, again, better than 6 nines of all the biological pathogens. And this is key for treating immune-compromised patients, for example, that are very susceptible to airborne contamination. The technology can be applied in various market sectors. There's, of course, a widespread need for pure air, from industry, pharmaceutical manufacturing, agriculture, waste, transportation, protecting passenger cabins, and the military applications, protecting shelters, especially portable shelters, and rooms in medical facilities. And it can be incorporated into healthcare facilities, hospital rooms, burn treatment, patient waiting rooms, etc. And to reiterate and compare to the conventional technologies, it destroys the 6-9 log kill of all airborne biological pathogens, bacteria and viruses before they reach any HEPA filter, significantly lowers the probability of mold and live pathogens growing on filter surfaces. The efficacy remains constant over time. As long as the machine is running, it's working. It lowers the frequency, cost, and time invested in replacing filters, and eliminates any worker exposure to live hazards on filter surfaces. Now, in the conventional air movers, live biological pathogens and virus can collect on HEPA filters. There's a high probability that mold and pathogens grow in the filters. And furthermore, there's a high frequency, depending on the location and implementation, of the cost and time to replace these filters. And there's also the creation of another waste stream. And there's some concern about the effectiveness of HEPA filters against small virus particles. Thank you. That's the formal presentation.
Thank you very much.
And Mr. Barrett, just to make some concluding statements, that this technology came out of the State University of New York at Buffalo after multiple years of research, and was very recently, this technology was accepted by the state government as one of the 12, we were approved as out of the 12 companies, YFS and SteadySpace was the only technology that was actually endorsed by the state government of New York to fight against COVID-19 for airborne infections. The company holds the worldwide patents all over the United States, in Canada, in Europe, and in Israel. The nearest competition to this technology is actually from none, because the HEPA filtration has already been proved to be inadequate and inefficient to handle the virus infections, because viruses, they cannot be trapped by HEPA filters. And the UV light is one of the other technologies that they claim about the control of the airborne infections, but SteadySpace has a leading edge over that. Currently, the technology is being marketed in the United States and aggressively we are pursuing with the Department of Defense and various state governments. Thank you.
Thank you very much. I think the relevance for this, and given the last year or so, has improved or has increased greatly. And I imagine the last year has been incredibly busy for you, given what's happened. I'm going to hand over to a couple of questions that we have.
Yes, I hope you can hear me over there. Just like to quickly ask, how many machines are needed for, so let's say, a building, or for like a hospital or a hotel, let's say even a conference room, and what is the cost of these devices?
Well, the device can be scaled, and it mostly is scaled up by the size of the blower. For example, we've built units that range anywhere from 250 cubic feet a minute to up to 5,000 cubic feet a minute, which can be used to treat the sections of a building or a building itself, depending on its size. The key performance measure is the number of air exchanges that can be accomplished in a given space with that flow rate, and the cost scales from operation. The cost of electricity to operate it is the essential main cost of operation. And again, the capital cost scales with the size of the device.
Yeah. And currently we are in conversation with the Department of Defense, Army Corps of Engineers, where they're talking about the buildings that would be immune from these kind of deadly pathogens, and SteadySpace is being considered for the same purpose, for having the protected buildings.
Okay, yeah, I'm really just trying to get an idea of what the cost would be, and also how easy it is just to install it into, let's say, some kind of building or a room or whatever it is, because if the costs are really high, let's say for a hotel, it's got 300 rooms or something. Yeah.
So the cost would depend upon where the steady space has to be installed. It could be, so if one room has to be protected, the cost is going to be significantly less as compared to protecting the whole building. Anywhere, the starting point would be somewhere to $50,000 for protecting a smaller area. And as the technology is scaled up to protect the largest space or the biggest ever building, the technology would have to be implemented through the HVAC system, or it could be placed in an isolated manner. Then the price could escalate from $50,000 to a few $100,000 or even more, as I just mentioned, depending upon the size of the building.
I would add that one of our main products that's in the market now essentially is one of the smaller units that's made for a portable isolation shelter for contaminated patients. We're working with a shelter manufacturer who's developed a negative pressure shelter. Our unit attaches easily to that, and it's very straightforward to implement in that isolation shelter, where we keep a negative pressure in the shelter, the patient rooms, and then exhaust all the air through our machine to the outside, where after it has been decontaminated. But that's very easy to implement.
But his question is about the hotel, so let's say a hotel.
Yeah,
on
the buildings where you install and integrate into an existing air conditioning system, the installation is more complicated.
Hello, I have another question. What is your regulatory status, in particular any FDA approvals for medical devices and so on and so forth?
So this technology does not need a FDA approval, but we meet the CDC guidelines and the ASHRAE guidelines, which means that in compliance to all those established guidelines, the technology is to be commercialized under those criteria. We do not definitely need approval as a medical device.
Thank you.
Well,
Just a second question. Why is it that the air that comes out of your device needs to still pass through a HEPA filter?
It is not necessary for it to. It is not necessary for the air to pass through the HEPA filter. But if let's say the HEPA filtration is inadequate for the virus control, because anything which is less than 0.3 micron is not going to be trapped by the filtration system. So an organization or an institution or the new construction where recently the HEPA filtration is already in place, and now they want a technology like SteriSpace to combat any potential airborne threat. If it is there, it would be synergistic to SteriSpace. But if it is not existing, it would still not matter, because SteriSpace on itself will take care of any kind of airborne pathogen inside that space.
Thank you very much.
So it is not necessary.
Thank you. Time for one more quick question. Are there any moving parts in the device? And do you have the data on what the mean time between failure is?
I'm sorry, the mean time between?
Between failure. If there's any moving parts, is there an average time of which they may fail?
Yeah, there are the blower, and we use different types of compressors or blowers to do the compressive heating, but usually only routine maintenance of changing the oil in the blower is required, and we've not experienced any blower failures. The remaining parts are just passive, and so we really not experienced any failure. It's automatically controlled, and it's been tested over 24/7 operation over a significant period of time.
Thank you. And then quickly, what is the peak temperature needed for the sterilization of viruses?
All the testing we've done indicate that if we heat the air at the outside of the blower to 460 Fahrenheit or 240 C, then we've pretty much killed all of the biologicals across the board. We can destroy virus at lower temperatures than that, but to be safe, we usually use that 240 C as the treatment temperature.
240 C. Okay. Thank you very much. That was very interesting, and thank you for joining us today.
Thank you, Mr. Mayor. Thank you.
Dr. Sean.